Well, here we are in part 2 now of the elasticity video. And why does it matter whether demand is elastic or inelastic, or as it says here, we can see demand 1 is relatively inelastic and D2 is relatively elastic. Suppose supply increases. When supply increases in a market, it creates downward pressure in price. Our business person is at E1 and has been charging $100 and selling 10 units. And those 10 units represent so many customers, say 10. Now that may be 10,000, 10 million, but that's the customer base. So why does it matter? Well, let's first look at the relatively inelastic case. In this case, we start with a $100 price at E1, we move to a $70 price at E2, and that represents a 35.3% drop in price. Remember, using the midpoints formula, midpoint here is 85. Then from 10 to 14 represents an increase in 33.3% of business. So price has fallen by 35%, but business has gone up, the quantity demanded has gone up by 33. So using our elasticity of demand formula, ignoring the negative sign here, we have the percentage change in quantity demanded over the percentage change in price. And since price is negative, ignoring the negative sign gives us a positive anyway. So we have 33.3 over 35.3, and that's equal to 0.94. Now, that happens to be less than 1. So we say that this is an inelastic demand curve. It's absolutely inelastic because of the number. It's relatively inelastic when compared to D2. So what would a price fall do? A price fall here would decrease revenue. So price has gone down and total revenue has gone down. How do we know? Well, total revenue 1 would be price times quantity, or 10, let's see, 100 units times the $10, or $1,000. And total revenue 2 now is equal to the $70 price times 14 units, or 980. That is a $20 loss. Not a good idea if I were making that price drop. But again, I'm subject to the market here, so there's not a whole lot I can do. What about the relatively elastic case? Here we're starting at E1 and going to E3. At E1 we have $100 and we have our initial 10 units. But at E3 we're going to 20 units and the price is going to fall to 70. So what happens here with this increase in supply, that creating downward pressure on price, is that the elasticity of demand is equal still percentage change in quantity over percentage change in price, and that's going to be equal to what we have here is I'm sorry, wrong number here. We're going to use 90. Remember, this is less of a fall, and that is a minus 10.5% fall here with our 66.7% increase here. So as we go from $100 to $90, that is a 10.5% drop in price, 66.7 increase in quantity, and that's an elasticity of 6.35. That's greater than 1. So we call this curve absolutely elastic. Now what happens then when price falls along an elastic demand curve? Price falls and total revenue goes up. Why? We attracted more customers in through our price fall than we would have lost revenue per unit. So let's take a look. Total revenue 1 is equal to 100 times 10, or 1,000 That was our beginning point, and total revenue 3 is equal to $90 times 20, and that's $1,800, and that's $800 to the good. That's really super. Well, let's look at one more thing before we finish, and that is the in cases, if you will, the extreme cases, the perfectly inelastic demand and the perfectly elastic demand. When supply changes, same supply changes, S1 to S2, increase in supply from S1 to S2, all we see here is a price fall. The elasticity of demand being 0 means that we're simply losing revenue. Over here, S1 to S2, not sure what that was, what we find, not sure how all that occurred. Okay, what we find here is an increase in quantity, but there's no change in price. We say this is an infinite elasticity, and indeed all the benefit here is to the increase in supply has all become more quantity sold by this particular demand. Okay, I hope that was helpful.